can't be. Okay, so let's talk about this problem really quick, just so that we can clear the air. So we did this correct. This makes sense, right? We found the tangent was -5/3. We plug it in, and we solve for secant squared. We got down to that secant squared equaled this. We took the square root. We knew it had to be the negative because it was in quadrant number 2. Do we all agree with this? Yes. Okay. All right. Now, the reason why I can't just say that this is 5 is because I don't know if the radius of the circle was 1. Me saying this is 5 was me assuming that the radius of the circle is 1, and I don't know that, so I cannot make that assumption. And so therefore, saying that this was just 5 is absolutely mathematically incorrect. What I can say is that because secant theta equal, what was it? Negative square root of 34 over 3. That means that cosine theta equals -3 over the square root of 34. Agree? Yes, still with me? Okay, and we know that sine squared theta plus cosine squared theta has to equal 1. Yes. So I plug in what I know and I solve for sine. I don't know sine yet, so I have sine squared theta plus cosine squared theta, which is -3 over the square root of 34 squared equals 1, which gives me sine squared theta plus 9 over 34 equals what? I'm going to subtract 9 over 34. Still with me? So subtracting 9 over 34. And after I subtract 9 over 34, that's going to leave me with sine squared theta equals 25 over 34. And then I have to take the square root of the numerator and the denominator. Because it's in quadrant number 2, sine theta has to be positive, which leaves us with 5 over the square root of 34. Mathematically, I can't leave it like that. So therefore, sine theta equals 5 square root of 34 over 34. And that now makes 100% sense. It's not because it's a square root. And it's positive because we're in quadrant number 2. Yes, that feels better. And it makes more sense. And that's because your radius isn't 1. Our radius was 30. Well, look here. It didn't feel right. I'm like, what were you thinking? Like, but now it's right.